Hi everybody. In this video, we're going to start working with fractions. So for this part of your notes, we're going to title it an introduction to fractions and mixed numbers. Okay. And again, don't forget to put your date in or which week that you're working on just to help you stay organized. Okay. And I think probably a lot of this video will be review or just a refresher if you haven't seen it in a while. So we're going to go through some common definitions and then also talk about how to go between the improper form and a mixed number form. And you'll learn about those definitions in just a second. Okay, so for example, first of all, a fraction is just a part of a whole. So it's just a way for us to represent a piece of a whole or a part of a whole. Or if we have more than a whole, like an extra part, right? So an extra piece of it. So in our fraction, I'm going to give you an example here. Something like 3/4. So this top part here is called your numerator. And this bottom part here is called your denominator. Okay. This part here is your whole. And the top part really represents the part. So something like 3/4. So for instance, let's say I have a circle and I have 4 parts all together. So the whole thing is cut into 4 parts. And then maybe this is a pizza, and so I'm eating 3 of those 4 parts. So I have 3/4 of the circle shaded in, okay? Now, also as a little side note, this little line in the middle is just called your fraction bar. Okay, so if you just hear someone refer to a fraction bar, they just mean that little line that separates that numerator and denominator. And of course, we've seen that before because fractions are also another way that we can write division too. Okay, so let's say I have 1/6. So I'm going to use a rectangle this time just to kind of do something a little bit different. And I'm going to break it into 6 pieces. So 1, 2, 3, 4, 5, 6. And if I have one of those pieces, then I'm just going to shade in 1. So this is 1/6 of the rectangle. Okay, so that denominator there gives you the whole, so how many parts all together. And then the top part represents whatever part you're focusing on. So here I'm focusing on the shaded part of the rectangle. So I have 1/6 of the rectangle. I could say is shaded. So if I have 1/6 of the rectangle that's shaded, then I have 1, 2, 3, 4, 5 pieces that are not. So I have 5/6 of the rectangle is not shaded. Right? So we can write things based on parts that are shaded in, based on parts that are unshaded. It's really based on the context of the problem. So that numerator is going to be whatever you're focusing on for the part of that problem. A lot of times it tends to be the shaded part of an object, but it doesn't have to be. So we could also talk about the unshaded part, or we could even bring in a real world example here, for instance. One thing I do want to note here is that when we're dealing with fractions, you should have all equal sized parts. So sometimes that gets forgotten. So I know I'm doing this by hand, so it's not going to be perfect, but I'm trying to make my parts equal. So here I have 4 equal size pieces. Here I have 6 equal size pieces. So that's important too, that these are equal parts of a whole as we draw the image. And I'm just going to do one more example here. So let's say I want to do something like 3/5 of the figure. Now, maybe my figure isn't a circle or a rectangle. Maybe it's some sort of group of objects. So maybe I have something like 5 triangles. And then here I'm going to shade in 3 of them. So again, it doesn't have to be one specific shape. It could be an application, it could be a rectangle or circle, some sort of diagram, and so on as we're doing these different parts here. Or maybe I can say 1/3 of the cup is filled with water. So if I want to draw a visual, say this is my cup here. And I'm going to draw about 1/3 of it. So let's see if I break this into equal parts. And like that. Then 1/3 of it is filled with water. Okay. So that 3 tells me how many equal parts that I'm going to break this cup into. So you can see that I have 1, 2, 3 equal parts, and I'm going to fill 1/3 with water. Okay. So now I want to talk about a few more definitions and things too. So we have proper fractions. And these have a value less than 1. And what you're going to notice is that the numerator, so the top, is smaller than the denominator. So some examples here. Actually, all the ones we've just seen are examples. So 5/6, 1/3, 2/5, etc. So each of these has a numerator that's smaller than the denominator. And because of that, they have a value that is smaller than 1 or less than 1 whole. Now we also have improper fractions, and these have a value of 1 or greater. And what happens is the numerator is the same or bigger than the denominator. Okay. So examples here. Something like 4/3. Okay, so our numerator is bigger than the denominator. Or something like 9/7, or even something like 6/6. Okay, so if your numerator is the same or bigger, it's considered improper. And what happens is it has a value of 1 or bigger. So here, 6 divided by 6 is just 1. So hopefully that's one that you recognize. And then here, if your numerator is bigger than the denominator, then the value is going to be over 1. Now, improper fractions can also be written in a different way, as mixed numbers. So a mixed number has a value of 1 or greater. And then what you see is a whole number with a proper fraction. So for example, 1 1/3, 1 2/7, the number 1. So I'm just using our examples above and actually changing them into the mixed number form. It doesn't have to be 1 though for your first number. So you could do something like 5 1/2. So that would actually be the same as 11/2. Now I'm sticking with positives here, but you could do negative numbers as well. So these same definitions do hold with negative values. And the thing that's interesting is that we can actually switch back and forth between improper fractions and mixed numbers. So that's what I want to focus on next is, well, how do you go back and forth? So I'm telling you that these values are the same as these values right here. So they do match up perfectly right down the line. So how do you go back and forth between the two? And actually, before we go on, they're both good. So I know a lot of times you'll see, you're probably used to people saying like, oh, we don't like improper fractions. But improper fractions tend to be really easy to work with when we do computations. So we are going to use them, particularly when we multiply and divide, but also when we add or subtract fractions. Mixed numbers, I think, are more understandable for most people, right? It makes sense if you see something like 1 1/3, then you know that value is a little bit over 1. Whereas if you see 4/3, that's a little harder to understand what that means. So both of these are good. The positive of mixed numbers is that I think they're a little bit easier to understand what they actually represent, but improper fractions tend to be easier to work with computationally. So when we actually do calculations, so they both have their pros and their cons. So how do we go from a mixed number to an improper fraction? So for example, let's say I have the number 2 1/4. Okay, how do I make it an improper fraction? So what you do is your first step is you're going to multiply the whole number and the denominator. So in this case, my whole number is 2 and my denominator is 4. So you're gonna, multiply those together. So 2 times 4 is equal to 8. And then you're going to add in the numerator, which is the top. So I'm going to take that 8 that I already have here, and I'm going to add in that numerator of 1. So the value from step 2 is your new numerator, and the denominator will stay the same. So in our example here, our original denominator was 4, so it's going to stay 4. So my answer is going to be 9/4. So we're multiplying the 2 and the 4 to get 8. We're adding in the numerator. That becomes my new top, and then the 4 will stay the same. Let's do another example. Let's do 5 6/7. All right, so I'm going to do the shorthand this time. So we're going to multiply the whole number in the denominator. So we multiply these together. So 3 times 5, 5 times 7, I don't know why I'm saying 3. 5 times 7 is 35. And then you're going to add in the 6 from up top. So we're going to add that 6 in to get 41. So 41 is our new numerator, and our denominator stays the same at 7. So easy for us to go from a mixed number to an improper fraction. And again, why would you want to do that? Well, improper fractions tend to be easier to do the calculations with. So sometimes it is helpful to go back and forth. All right, let's go the other way now. So let's do one of the examples we've already seen, 11 halves. So what you're going to do here is you're going to go ahead and divide the numerator by the denominator. So I'm going to set this up as 11 divided by 2. And we're going to do our long division there. So 2 goes into 11. That's going to be 5 times, which is 10. 11 minus 10 is 1. So I have a remainder of 1. Now, if you need to do your multiples list here for more complicated problems, you would still do that. All right, so the whole number part of your answer, so in this case, the 5, is also the whole number in the mixed number. The remainder is the numerator, and the denominator stays the same. So this 5 here stays as my whole number. The remainder is going to be your numerator. So it's going to be 1, and then your denominator stays the same. And there's our answer, 5 1/2. All right, let's try one more example here. How about 55 fourths? Okay, so the first thing I'm going to do is I'm going to set up my division. So I have 4 going into 55. And again, if I want to do my multiples list, I can go ahead and do that. 4 goes into 5 one time, which is 4. 5 minus 4 is 1. I bring down the 5. 4 goes into 15 now. That's going to be 3 times, which is 12. So I have a remainder of 3. So that 13 is going to stay as my whole number. That remainder is going to be my numerator. And then my denominator stays the same. So 13 3/4. Now, just as a little side note here, you can also draw pictures of improper fractions and mixed numbers. So I'm just going to do one kind of quick example there. All right, so let's do an example of 9/4, which is an improper fraction. And there's different ways that you can draw this. So notice that my whole has groups of 4. So I'm going to use circles here. So I have 4 there. Now I have 9 shaded in all together, so I need another group. So I have 4 plus 4 is 8. That's still not enough. And then now I have 12. So now I have more than enough. So what we do if we're drawing a picture of an improper fraction is you're going to use your denominator there to figure out how many pieces should be in each whole. And I'm just using circles. So I know each whole has to have 4 parts. But I want 9 pieces shaded in. So I need to have, in this case, 3 groups to have enough pieces. So now I shade in 1, 2, 3, 4, 5, 6, 7, 8, and then there's 9. If we go ahead and change this over to a mixed number and do my division, I see that 4 goes into 9 2 times, which is 8. And I have a remainder of 1. So this becomes 2 1/4. And notice that if you look at your picture here, it matches, right? I have 2 holes shaded and 1/4 shaded. Okay. So we can draw the pictures as well. I think most people find drawing the picture of the mixed number easier because you can clearly see 2 holes and then just draw that 1/4 extra piece shaded in. But you can also do it with the improper fractions. Now just remember your denominator is always telling you how many parts are in the whole. So our denominator tells us how many parts are in the whole. So that's really important when you're drawing a picture or when you're trying to set up a fraction with an applied problem. And then that numerator is really like how many pieces do you have or how many parts are shaded in. Okay, so just a couple little tips along the way here. Okay, so another thing I want to talk about here is kind of part of our introduction is how do we graph fractions on a number line? Okay. So let's say I want to graph 3/4 on a number line. The first thing I do want to note here is that this is a proper fraction, right? The numerator is smaller than the denominator. So when it's a proper fraction, its value is less than 1. And again, I'm talking about positive numbers here, so the value is less than 1. If I had a negative in front, it would be between 0 and -1 instead. So to graph this, I know I'm going somewhere between 0 and 1. And remember, the denominator tells you the number of parts in the whole. So what I'm saying is that each whole has to be broken up into 4 pieces. So my whole here is from 0 to 1. So if I break this up into 4 parts, so 1, 2, 3, 4, then I'll be able to much easier see where I should graph 3/4. So I have my parts of 4 here, and I want to be 3 units in. So 1, 2, 3. Let's say I had instead 1 3/4. So now I have a mixed number, and notice that I have 1 3/4. So this value is between 1 and 2, right? So it's bigger than 1, but I don't have another whole yet, so it's less than 2. And again, my denominator is in 4s. So I'm going between 1 and 2. And I'm breaking that into 1, 2, 3, 4 pieces. So I'm going bigger than 1, but less than 2, and I'm 3/4 in. So this is this value right here. All right, let's try another example. How about we do 2/3? So again, this is a proper fraction. So its value is less than 1. So its value is, in this case, because it's positive, between 0 and 1. So on my number line here, going between 0 and 1. The bottom tells me that I have 3 parts in my whole. So I'm breaking this into 3 parts. So 1, 2, 3. And my value is a 2 here, so I'm going 2 parts in. So 1, 2. So there is 2/3. Okay, let's try one more example here. So I have 11/6. Now this time I have an improper fraction. So for improper fractions, you can graph in the improper form, or if you prefer to change to a mixed number, that's fine too. So I'll kind of show you both ways here, and we'll start with the improper form. And again, don't forget that the denominator tells you that number of parts for our whole. Now, I do see that I have a improper fraction here, right? So the value is greater than or equal to 1. So it's going to be at least 1, if not bigger. So I'm going to start here at 0, 1, 2, 3, and 4. So I know I'm going bigger than 1 here. And it tells me that I have to break it into 6 pieces for each whole. So I'm going to try to squeeze that into my example here. Let's see how we do. So let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 4, 5, 6. Okay, so I have all my parts broken up. And again, remember, fractions are equal pieces, so I'm doing my best to make all my parts equal size here as well. And this time we're going in 11. So I'm going to start at 0. I'm going to count in 11 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So right here. Now, when you're graphing, make sure you also count the whole. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 as we go in. So that's where 11/6 is. Now, I think it's a little bit easier to see as a mixed number, so you may want to go ahead and just change this over. So 6 goes into 11 only one time, and you can see that you have a remainder of 5. So this is 1 and 5/6. So now I can see the value is between 1 and 2, right? So now it's a little bit easier to see like where I'm actually looking, whereas before I was just kind of drawing numbers, not really sure how many I had to go by for my wholes. But here I can see it's between 1 and 2. So my 1 and 5/6 is a little bit over 1. It's actually almost to the 2 mark, right? Because 5/6 is almost a whole thing shaded in. And you can see that on the number line here, it works. So we're between the 1 and the 2. And I'm going 5/6 in. So I'm going 5 in. 1, 2, 3, 4, 5. So I get that same exact mark, whether I'm graphing as an improper fraction or whether I'm graphing as a mixed number, they're both fine. All right. One last thing I just want to remind you of, and it's nothing new, it's just kind of a reminder. Okay, so don't forget we cannot divide by 0. So just a couple examples here. So if I have something like 5/0, this is undefined. Okay, so we cannot divide by 0. That still goes for fractions. You cannot have a 0 in that denominator. But a 0 in the numerator would be fine. Okay, so if it's 0 over 7, that means it's just 0. So you have no parts shaded in. If you're dividing by 1, so let's say I had 6 divided by 1, you get the value of 6. So remember that 1 in the denominator is still division by 1. It's not going to change that value. We do use 1s in the denominator quite a bit. So you do want to notice here that dividing by 1 doesn't change the value. And that's a really important idea that we're going to use later on. But something like 1 over 4th stays 1 over 4. Okay, so that does not just become 4. You can only kind of cancel out that 1 if it's in the denominator. If it's in the numerator, that's totally different. These are very different things. So you just want to be careful with your 0s and your 1s. So a 0 in the denominator is bad, it's undefined, but a 0 in the numerator is fine. Here, a 1 in the denominator will not change your answer, but a 1 in the numerator does. And this is a common mistake. A lot of students will take 1/4 and write the final answer as 4 instead, but that's incorrect. So if you have a 1 in the numerator, don't cancel it out.